Hello. Hello, I think my voice is audible. Hello. Okay, let me post about this stream. Let me check the stream on. Wait a minute, we will start this live in a minute. No. Okay, about the question, there exists an infinite number of points, okay, and it extends towards x-axis, okay. We have some queries like two types of queries, 1 comma x and 2 comma x comma size. What we need to do at operation 1 we need to place an obstacle at a current x location. In operation 2 we need to find a block of size a block of size empty spaces, means we need to find a consecutive spaces of length greater than or equals to size. If yes, we need to return true, or we can return. Do we need to return true? Yeah, we need to return true. So that we don't need to place any block at there. Just we need to simply return a boolean type. If we do this if we solve this in a brute force way, it's impossible. Like we can't we will get a TLE. So to solve this in an optimal way, I'm thinking of an approach, but I don't know whether it will work or not. Sildra, let me explain my approach. My approach. Okay. Wait, let me share the. This is a lead code problem of the day today. question. Hope you guys find it. Hmm. Okay, what question states that? Wait, let me shift to a pen. What question states that we had like an x-axis, like here the point holds zero from zero and it extends to infinity. Assume it's infinity, like infinity. So for query one, like query type one, we have like x. So x is a coordinate lies on x-axis, right? So we need to place an obstacle here somewhere x. If x equals to 20, we need to place an obstacle at coordinate 20. So by placing this obstacle, we are splitting this 0 to infinity into some blocks like 0 to 20 and 21 to infinity. These are the empty spaces in between the like 0 to 19 and 21 to infinity. These are the empty spaces that we have now. So, and assume like you have another query like place a block like block at 10. So you place another one here, another obstacle at here. Now you gave a type 2 query. Like query type 2 states that you have given an x comma size. So within the range of 0 to x, do you able to find any empty continuous empty blocks of size sz? So for assume like we have we have 0 to 21 like given x equals to 21 and the size would be 11. There are no continuous 11 blocks, 11 empty blocks in the range 0 to 21, right? So answer would be false. If the size is like 9, so the answer would be true because in 0 to 10 we have 9 empty blocks and between 10 to 20 also we have 9 empty blocks. So here the answer would be true. So we need to find out in an optimal way. So to find that, I am using something like topics that I'm using here: binary search, segment trees. I don't know as the actual solution. I am just trying to implement my solution. How I am going to solve this, right? That's the main question. To solve this, what I am going to do is initially I take like here they clearly mentioned the size, the value of x would be minimum like at most 5 into 10 power 4. So what I am assuming is I am assuming like I can take from 0 to like 6 into 10 power 4. This is my range, actual range. I don't think it will go again like up than this, or we can use simply 5 into 10 power 4 because we only use the value x as a range, right? So if x doesn't go up than this, then the answer like it's waste of memory to use 6 into 10 power 4. So I am using simply 5 into 10 power 4 plus 1 kinda just for bounds constraints. So in this range, I am using segment trees to allocate the current block size. Like every value holds the like we have some value at 20 here. This 20 also have some value like what is my current block size. The current block size is 5 into 10 power 4, right? So every value I am storing this value in every block. Later when I am splitting at 20 40, what I am doing is I am doing a range update in the left side and right side. Do you understand? Both in left side and right side, what I'm doing, like up to the ends, what I'm doing is I, the actual block size is 5 into 10 power 4, right? So plus 1, right? So what I'm doing is I am subtracting the left block size in the right side, like I'm doing minus, assume this is as left block size, and this is as right block size. I'm separating left block size in the right side and the right block size in the left side. So by this we can now, in this each and every value, what we will have is like something like 39 in every value, because whenever we subtract 5 into 10 power 4 plus 1 minus the right block size, it will simply give the leftovers block size. So we can simply use that. In future, we get any query like up to 41, check is there any values, any block that continuously available greater than 30. What I'm doing is I'm performing max operation. So here, what if I store maximum query? After subtracting, I will do like range maximum. In segment trees, the segment tree works on max in range. Then it will retrieve what is the maximum continuous block that this range holds. It will simply return 39. What I required is 30, so the answer would be true. But here is another catch. Whenever we are doing the range, whenever we are doing range subtraction operation, like range addition or subtraction, it also takes some time complexity errors kinda. So what I'm gonna do is I'm gonna use some lazy propagation will work. But also thinking of in another way, that can we can we use square root decomposition? Square root decomposition, we can also use square root decomposition, which will process each query into like the time complexity would be square root of q into square root of 5 into 10 power 4. So we can either use segment trees or square root decomposition, or we can use Fenwick trees. This is a much elaborated concept. I'm not using this. So how can we solve? Can we go with the segment trees or square root decomposition? How can we solve it using square root decomposition? The square root decomposition holds that it divides the block into square root of n chunks. So, and no, we can't do square root decomposition. It will only give the empty blocks list, not a continuous blocks list, right? So it would be, I think, simple binary search would work. But in range, the binary search will also give me error. So segment trees were the best plan. Segment trees are the best plan. Any comments that I miss? Okay, none. Hmm. Segment trees is my current best plan. So starting the coding part. So I'm also using lazy segment trees, right? Some lazy value to update laziness queue queries. Currently, I'm gonna create class seg tree, class seg public. You need to have some knowledge on how segment trees work. Okay, initially I list out what I have to do. That would be a better plan. Build a segment tree. For range max thing. For range max, we need to build a segment tree. Mm, I'll build a lazy propagation sig tree to update the lazy operations. Hmm. Do we really need a lazy operations here? Okay, I will think about it while working on. After building lazy propagation, what we have to do is in main function here we need to create a list. Yeah, we need to create a sorted list where we will insert what I want is we need to find where we will insert each val into that list, and each val in the sense inserting obstacle coordinates. We are inserting obstacle coordinates here. After inserting obstacle coordinates, what we gonna do? For size one query, like for Q1, we simply do range subband lazy prop. For Q2, we initially do lazy props and lazy propagation and we do lazy propagation and we, we retrieve range max. Hmm. Yeah, and check whether the range max was greater than current block size. This is my approach. I would like to listen your approach, yogas. I meanwhile I will check will this work before proceeding. You guys think will this work and let me know if it's not in the comments. Yeah, I know it will be solved using segmentaries only. Yeah, we will proceed with our approach. In our approach, we need to first build a max segmentary, which will retrieve max values. Vector means n and value to be stored. Hmm. So we need to go for updates, right? In one update, I have just have to increment a value and increase max. Update type 1 and update. I have two types of updates here. Hmm. Update 1 takes L or index ID. So if L equals to R, I simply increment the value. No, no, no. For type 1, what I have to do is, yeah, here I need to place the value, right? L equals to ID. Return. Hmm. Oh, any viewership? Here we need to split the block at this would be a range update, right? Hmm. This would be a range update. So what we were now, lazy update. Hmm. If I, yeah, this would be range updates. So what we gonna do? Range lazy updates. So we have to update. We don't have to update everything. I have like x 0 to x. We need to update our values like doing sub. So how can I do a range lazy LZY? Lazy dot end, lazy dot begin, and filling it with zeros. Like no lazy need to perform. So I have to keep zero text in lazy. Hmm. Bit two int L, int R, int X, int ID, and int ID here and VL value. Assume it like addition operation, but we will add with the minus values. So like that it will neutralize if R, if R, no, R will never go greater than, if R, no, I will initially write below conditions in M equals to bar to if, if M less than mm, if M less than R, then LZY lazy of M R. In query part, we need to handle perfectly so that it will retrieve the like correct answer that needed. Okay. So in query is what is the query states that what is the max block in range 0 to x. Hmm. L R X ID. If L greater than X return 0. First initially we need to process lazy, right? So about processing lazy, size would be size not necessary I think, but we will store it. 4 star n plus 1. L equals to R. If L equals to R, just to do that lazy operation here. So SC ID plus equals to LZY of ID. SG, right? Lazy of ID of ID equals to 0. Return SG of ID. Now G of ID plus equals to LZY of ID LZY star ID plus 1 equal plus equals to LZY of 2 star LZY of ID LZY of 2 star ID plus 2 plus equals to lazy of ID lazy of ID equals to 0. After updating, the m equals to L plus R by 2 L plus R by 2 return query of L comma M comma X comma 2 star ID plus 1 plus query of M plus 1 comma R comma X comma 2 star ID plus 2. Yeah, that's it. This is a query of type 2. I want maximum, right? So max of. So I think the same query would work for both cases. So no need to mention type 2 query because the other thing will just holds the lazy as 0. Okay, this is my segment tree. Building segment tree was done with the lazy propagation. This part was done. we need to proceed with the remaining part. We need to like this sorter list, creating a sorter list to store each and every. Yeah, we will create that. Seg seg one for segmentary updates and another for like o1 o2. O1 will store what is the n. N comma values also n. In o2 n comma 0 qn equals to q dot size. For int I equals to 0, I less than qn, I plus plus, int t equals to q of phi of 0, int x comma sz. If t equals to 1, x equals to q of phi of 1. If x equals to 0, x equals to n size. If type 1, else type 2. Type 1 is about placing the blocks, right? First, we need to place obstacle in O2. We need to place obstacle in O2. So O2 dot UPD1 0 comma n minus 1 comma x comma 0. Yeah, it would be, it will place the block there. Now about a lazy propagation update. O1, like what we need to do, when we get an update, we will roll back to the, we will once check the dry run again. What will we do when we get an update? So so we had a line like this. We had a 0 here. We had some points like 10, 17 and 25 here and 50 here. Oh, okay. We got a new point like 30 here. So what we have to do is we need to find the previous block, 25. So what these blocks currently hold? All these blocks currently hold like 30 minus 25. Assume like 17 minus 10. 17 minus 10 would be 7, but there are only 6 blocks open, right? So L R minus L minus 1 would be the number of blocks. So here we need to pass n minus 1 here. Okay. Now when we place a block at some place, we need to find its previous ID and next ID. Okay. What we need to do is from previous ID to current ID, we need to perform update, and current ID to next ID, we need to perform update. What we need to update? Like assume it's like 35. It would be easy now. So 35 minus 25, we have 26, 27, 28, 29. We have 9 values. Yeah, 9 values. But when I place 30 here, what we still have 8 blocks left. In that 8 blocks, what we need to remove is, like in every value in 9, what we have to remove in the left side. The right block occupies 30, 31, 32, 33, 34. Like 35 minus 30 minus 1, 35 minus 30, 5 blocks, and minus 1 for 32, like also 30 including, right? So 4 blocks. Okay, okay. Now we need to remove 4 from these things and remove same opposite kinda like this. So in update, what I am doing here, not this kind of update too. Hmm. In update, this update for type 1. In this update, we need to like add values from L to R, like QL to QR. If QL like L greater than QR or R less than QL, return. Else, if it's completely in the block, like QL is less than or equals to L and QR is greater than or equals to R, like R is less than or equals to QR, then we simply do lazy operation there. Else, we split up and check that again. Yeah, go to dot. Like first we need to find the previous value, previous value for x, and next value for x, previous value and next value. How can I get next value of x? How can I get that? Hmm. To get the next value, how can I get the next value? That's the question here. What can I do to get the next value? Here 30. How can I get 35? How can I get 35? What we can do is, can we simply check what's the value at 25 first? We will simply check value at 25 plus 25. First we need to find the previous value, then find its value, and then add that value to the current previous value. We will get the next value. That's it. That's the only way. First, let us find out the previous value. PV equals to O2 dot QRY 0 comma n minus 1 comma inquiry inquiry LRXID. So x minus 1 ID would be 0. See out previous one. Okay, let us test is previous value was working or not. Like what would be the cases here? Placing it obstacle 25 and next placing it obstacle placing obstacle at 35. Okay, the output should be 0 comma 25. Comma 0. Okay, let us check. So we need to return an array, right? Queries must contain URL test case 1, 2. Ah, Wait, what? Okay, we need to at least place one, two type query, right? Two. Okay, we will change this to two, five. Why still error? Here we will change up to 9. Update 2 had an error. Okay, here QL, QL comma QR. Same goes to here. Wait, what? Hmm. The answer is 0. 'Okay, the number of query size depends on query's length, right? Okay. Okay, no problem. Here why it is 1, placing 2 there, placing at 5 1, and checking how many are there at 9. Is update going on correctly? 5, like 0 it's updated, 2 it's updated. Okay, we need to place I here. Here 5, here 2. Why here 5? L equals to R. Okay, it's going to 5000 also. Why did it reach to 5,000 here? Here, no necessary. Here, why? From zero. Okay, I'm ending the stream here.